write down the topic. Write down the topic work and energy. Work and energy. Under that, write work. So first, I'll talk about work, right? Work and energy. First, I'll talk about work, right? Okay, I think you have referred the note I sent you onto the group, right? Okay, right. So, work is a physical quantity, right? It is something like it is similar to the meaning of work actually. Uh, when you apply a force, let's say you apply a force, there's an object, you apply a force. When you apply a force, that force has to be like it has to move. Force has to make a displacement unless there's no work done, right? So when you apply a force, work done in order to make a work, that force has to displace. Only then we say that it's a work, right? If I just hold an object like this, but there's no displacement, then there is no work. In order to make a work, there must be both force and displacement, right? So without a displacement, there, if I just push this board, if this doesn't move, the work done by this force is zero there. So it is clear, in order to make a work, the force must have a displacement, right? So by multiplying force and the displacement, you can find the work. So if you have an object like this and you apply a force, then it makes a displacement S. Object is here, is moved to here. Then the work done by this force, right? There can be other forces as well on the object, but by this force, we can find using this equation, F times S. Take this down, and thumbs up if you are taking it down. The definitions are in the PDF, right? You can refer that PDF. Thumbs up if you are okay. Then say, let's say another scenario, right? You apply a force to, and the force is to this direction, and the angle between force and displacement is theta, right? Angle between force and displacement is theta. So in order to find the work in this case, what do you have to do? F cos theta. Always you consider the force to the direction of displacement, right? So to the direction of displacement, force is F cos theta, right? Not F sin theta. F to the adjacent side, it is cos theta. So you can say F cos theta times displacement. You have to take the component towards the displacement in order to find the work. Then you can say F S cos theta. So that is work. Work is Fs cos theta. So this is another scenario. Here the displacement occurs to a different direction, right? So this is work done by this force. There can be other forces on this object, but here we only consider this force. Okay, so Fs cos theta. Take it down as well. If you don't understand, let me know. So this is first case. This is second case. Right. This is the third case, right? The displacement occurs to this side, but the force is applied to the opposite side. So if there is a force, the object moves to this side, but the force is applied to the other side. So this is a similar like a friction, right? Friction. Always when friction applies, it is to the opposite side of the displacement, right? So in that case, we say it is a negative work. Work done by this force, these are usually resistive forces, right? It resists the motion of the object, resistive force. Okay? So you get a negative here. So the work done by the resistive force is negative. W equals minus Fs. Okay? Understood? So this type of force decreases the energy of the system. It always dissipates the energy of the system. These are like friction, right? Friction. It always dissipates. So we say that work done by this force is minus negative work. Got it? It is negative work. There can be other forces on this, right? But the work done by this force is negative. Okay? Take it down as well. And thumbs up, right? Once you taken it down, thumbs up. Right. In the tute, get the tute, right? In the tute, try the first question. First question. And send me the answer. Send me the answer. Everyone send the answer, right? It doesn't matter whether you got the wrong answer. I need to know whether you have understood or not. Yes. So yeah, third one is the answer. So both teams are applying a force, but there's no displacement, right? Since displacement is zero, work done is zero. So it is obvious, right? Only force, there's no displacement. Right, then try second question. Second one. Second one and let me know the answer. Everyone send me the answer, right? I need to check the answer whether you have understood or not. Farouz, are you first one? Okay, right. Let's see. So in the question, 50 kilogram is held at 2 meters. So you are holding 50 kilograms at 2 meters. Okay. Is there a displacement? This is not you are lifting this one. In the question, they don't say you lifted this one to 2 meters. They are just saying you held. You held, right? Is held at a 2 meters. So are you doing any work? You may feel tired there, but by the definition, there's no displacement here. The displacement is just given you to bluff, right? It is just, so what's the work there? It is 0, right? Understood? Fifth one, got it? Understood, right? You are just holding it like this. There's no displacement. Displacement is a must in order to make a work. If there's no displacement, work done is 0. Got it? So the answer should be fifth one. Okay. Then try third question. If you have a problem, let me know. Try third question. Third question, you can draw a sketch if you want. So the third question is regarding Cartesian plane, right? Those who got the answer, let me know. So this is 0, 3. This is, sorry, this is 4, 0, right? This is 0, 3. So the object is moved to this direction by applying a force to the same direction, 5 Newton. So the force applied is 5 Newton, right? It should mention that the force is applied to that same direction as the object moves, right? So what's the force? 5. Displacement. So this is 4, this is 3, and the distance should be 5 meters. So the answer should be 25 meters. The answer is not there. Answer should be 25. It's not 15. The answer is not given, right? It should be 25. Right. Then try fourth question. Fourth question. So these are easy questions, right? So we'll just go through. Try the fourth question. displacement, the object is moved along this line. So this distance is 4, this distance is 3. 3 squared, 4 squared. Take the root, apply Pythagoras to find this distance. So it is 5. Understood? Okay. Then try fourth question. So all you have to do is just multiply force by distance to the same direction, right? You always have to take the force to the same direction as displacement. Try fourth one. Let me know the answer, then I'll explain. So here what do you have to do? Force you know, but you don't know the displacement. So you have to find the displacement using what? Using an motion equation, right? Okay. So how can we find that? Time is given, so I'm going to use this equation. Initially it is at rest. So u is 0 plus half acceleration. You have to find the acceleration here. So there's this force 2 Newton and 5 kilogram. Just apply F equals ma to find the acceleration. Force is 2, mass is 5 a. So acceleration is 205. Just substitute it here. Time is 10 squared. 2 cancels off. 100 divided by 5, that is 20 meters. Now we know the displacement. Force is 2, displacement is 20. So the answer should be 40 joules, right? Fs, work is 40 joule. Did everyone got the understood that? Right. Then try fifth question. Fifth question, you first draw a sketch, right? Before trying the fifth question, draw a sketch. Then try that. And let me know the answer. So it is like this, right? It is an inclined plane. The force is not the inclined one. The sliding plane is inclined. So force applied is 20 for a distance 4. So just Fs, right? All you have to do is just force times displacement. 80, right? Yeah, 80 joule. 20 times 4. Answer is the first one, right? 80 joules. Okay. Then try wait. Try 7, not 6, right? Try 7th. No, you don't have to consider that. There's a mg sin theta, but what they ask is work done by 20 Newton, right? This does some work. Mg sin theta does work, but it doesn't matter, right? They are not asking anything about that. They are asking work done by 20 Newton. This also does work, but they are not asking to calculate that. There can be many forces here. Those forces do work, right? There can be friction. There can be weight. But they are not asking about work done by those forces. They are asking only about 20 Newton, right? Right. Then try 7th question. 7, right? Not 6. 7th question. These are simple questions, right? You will have an excellent knowledge once we complete these questions, right? Without any doubts. Right. 7th question. If you have any doubts, let me know. Okay, right. So let's see how to do this. So this is somewhat different, right? So here they are asking about, now listen, right? They are asking about work done by tension. So there's mg, right? That is a weight. They are not asking work done by weight. They are asking about work done by tension. Okay. When you lower this to a simple h depth, before all that you have to find the tension. So they say this is lowered at this acceleration. So this is not gravitational acceleration, right? G over 2. This is less acceleration. So just in order to find tension in terms of mg, just apply F equals ma downwards. So this is mg minus t. Mg is downwards, tension is upwards, right? So mg minus t equals m acceleration. Acceleration is g over 2. It is given. So what do you get? Mg, take the t to the other side. minus mg over 2 equals T. So the tension is mg over 2. Get it? So likewise, tension is not mg, it is mg over 2. So you found that. And the tension is working upwards, right? Okay, so what is the work? They are asking about work done by this. Object is moving downwards, but the force is applied upwards. So it is a negative work that is done by the tension. That is a negative work. And how much is the force? Tension, right? T. That is mg over T. I'll just write T. And the displacement is h. Then substitute T. mg over 2h. Second one is the answer, right? The thing is there should be a negative sign there. Okay? So this is the work done by the tension. Tension does a negative work actually. Do you have any problem? Let me know. Take it down, and if you understood, thumbs up, right? Shayani, do you understand? Yeah, you can apply F equals ma upwards, but you need to get the same answer. But this acceleration you have to submit as minus, right? They say lowered at this acceleration. If you apply F equals ma upwards, it is not wrong, it is right. But usually we apply to the moving direction, F equals ma. If you apply it upwards, T minus mg equals m, here minus g over 2. Then you get the same answer. You get the same answer, right? Yeah. You can apply F equals ma to any direction, it doesn't matter. But usually you apply that to the moving direction, right? Usually. Because there will be some confusions when you apply to the other side, right? I mean, it is correct, but you might get the wrong answer there. Usually it's the moving direction, right? Okay. Okay. Now we have considered the forces. All these questions, the force is constant, right? Did you understand that? Force is constant. Okay. So I'm explaining the theory using the questions. Force is constant. Above that, as a subtopic, above all the questions we discussed, right? Using a red pen or something, right? F constant. So all those questions are under F constant, right? Force constant. Right? F constant above all the questions, right? F constant. So you can just multiply force by distance, force by displacement, only if F is constant. F is constant. Got it? F must be constant, otherwise you cannot just multiply force by distance. I mean force by displacement. Got it? So the remaining questions is regarding varying forces. Okay? Under here, right? F is varying. Force is varying. So it is the next set of questions, right? Force is varying. So when you have a variable force, meaning for previous case, all the forces were constant, right? Every force is a constant. If it is 10 Newton, it is just 10 Newton. It doesn't change as it does the displacement. But here, force is varying. So this is a different set of questions. So whenever the force is varying, you have to go for what? The variation of the force must be shown by a graph, right? So this is shown by a graph. Then what can you do? Area of the graph. For these questions, you have to get area of Fs graph, force displacement graph, is equal to work. So you have to use this. Understood? They gives you a graph. Then you have to find the area of the graph in order to find the work. You cannot just put Fs, right? You don't know which F to use there. So you have to get the area of the graph. Take this down and then try 8th question. Take that down and try the 8th question. Let me know the answer, right? You just have to find the area of the graph. Okay, let's see. Sum of parallel sides. So this length is 4, right? This length is 8. 4 plus 8 divided by 2 times height 10. Oh yeah, 60 joules. Everyone got that? Okay. Then try next question. 9th question. Okay, let me know the answer. There's a slight difference in this graph. Right, let's see. So this has a negative displacement, right? The thing is to figure out whether this to be added or subtracted, this area. Okay, let's see, you have this object. Okay, origin is here. Origin means this 0 mark. For if this is positive direction, this is the positive direction. See, this force is always positive. Force is positive all the time, right? Then what happens? Force is from here to here. Direction of displacement and force is to the same. It is not opposite. So this area is a positive area. It does a positive work. Did you understand? This is obviously positive. So you just have to take the whole area as the work. Understood? Negative displacement means it is behind origin. That's all it means, right? So you have to add this. This is a positive work because direction of force and displacement is to the same direction. So it does a positive work. So just find the total area. So this length is 2, right? This length is 2. This length is 6 plus 2, 8. So what is the work? 2 plus 8 divided by 2 times height. Height is 4. What do you get? 20? 20 joule. Yeah, correct. Did everyone understood? 20 joules. Third one. Right. Okay, then try 10th question. Next one. So once we done with these questions, you will have a perfect understanding, right? Of work and energy. Right. Try 10th question. Okay, everyone send me the answer. Everyone send me the answer. So what's the answer? Here the area is 20, right? That is plus 20. Yeah. Here the area is 4 times 2 minus 40. Here the area is 20. So this is a negative area. Do you understand? This is a negative. Why is that? This is a negative area. So within this area, what happens? Displacement is happening to this side, right? Object is moving to this side. But here, force is negative, meaning force is to opposite side within this area. That's why this is negative. Unlike here. This is negative, right? Negative 40. Got it? So it is 0. Yeah, object doesn't change its direction. Displacement occurs to this side only. Got it? But here force becomes to the opposite side. So within this area, it is a negative work done by that force. Understood? Yeah, answer is 0. First one is the correct one. Uh, Here, when it is this side, because this x-axis is s, right? Displacement. If it is here, displacement is positive. If it is here, displacement is negative. But in this question, displacement is positive only. There's no displacement here. Got it? Did you understand that? Okay. Right. So regarding work, that is all you have to know, right? Now you know everything about work. So we can consider these types of question into two parts. One is when force is constant. Force is constant, you can just apply force times displacement. W equals Fs. But if force is not constant, in some cases force is not constant, they give you a graph, right? So using that graph, you can find the area which becomes the work. We didn't do 6 question, right? Try 6. Uh, that's a somewhat different question. Uh, just let me know the answer, then I'll explain. So let me know if is the force here a variable force or a constant force? Is it variable or constant? Not constant. This is x, right? Here x means displacement. X means displacement. So with displacement, what happens? Force increases. This case actually force constant, right? I think you are familiar with that. K is force constant. Okay. We discussed that when we discuss springs. No, you have got the wrong answer there, right? Because you thought that force is constant. You just applied this one. You cannot apply this. Why is that? Do you understand? When as displacement increases, force also increases. K is a constant. When displacement increases, force increases. So here you have to get a graph. So you can consider this to be y and this to be x. This is a y equals mx graph. So what do you get? Force and x like this. This is the graph for fx. Understood? This is a variable, right? Not constant. So you cannot apply fs. So you have to go for the graph. So area of the graph. Force here, this is 0, this is x1. So what is the force here? Just substitute x1 here. Then you can find the force. So the force here is kx1. The force increases from 0 to kx1. Then find the area. So what is the area? Triangle half x1 height kx1. So the answer is kx1 squared over 2. So this is the work. Did you understand that? Third one, if you have any problem, let me know. Everyone? Understood? Right. Take it down, right? So this is very important, right? So this K is called force constant. You might have learned this, right? So it is similar to spring constant, force constant. K is force constant, but this force is varying, right? Taking it down. Got it? Right. Okay. I think now you have a excellent understanding of work, right? We only talked about work. So everything regarding work, right? Then we have to move to energy part, right? Write the subtopic energy. Okay, so when it comes to energy, it is about energy conservation, right? Energy conservation. So the energy is always conserved. Okay, so what is energy first? Energy is actually ability to do work. Ability to do work is energy. Just take it down here. In the note it is given, but take it down here. Energy is, write down, ability to do work. Energy is ability to do work, right? So what does it mean? So if I lift this object, let's say 1 meter, what is the type of energy stored here? If I lift this one in the object, yeah, potential energy, right? Gravitational potential energy. Yeah, it is called gravitational potential energy. So I did some work, right? It is stored as energy. So once I release that, what happens? It loses potential energy, but it does work, right? Work means mg is downwards and it does a displacement. So it has the ability to do work. So more potential energy this has, more ability this has, right? So there are potential energy releases as it falls down, and it converts as work there. Got it? So energy is ability to do work. So work is, if you need to store work, so it is always in the form of energy. Okay. So energy is storage of work. You can consider like that. Okay. Right. Then below write types of energy. We'll write that types of energy, right? Take it down. Write down kinetic energy. So you know kinetic energy, right? Due to velocity or motion, kinetic energy, comma, gravitational potential energy. Gravitational potential energy. Comma, elastic potential energy. You can write PE. Elastic potential energy. So in this lesson, we mainly talk about these three, right? Write something like this, then put. So these three is what we call mechanical energy. So this is categorized under mechanical energy. Kinetic energy, gravitational potential energy, and elastic potential energy is categorized under mechanical energy. Take it down. So other energy types, what are they? Thermal energy, meaning heat. These are not mechanical energies. Only these three considered as mechanical energy. After that, thermal energy, then electric energy, electrical energy, chemical energy. Likewise, there are many energy types, right? Got it? Did you get it? Okay. Under that, right, there's some theory parts, right? I'll just give you because these are like very crucial. Under all these, right, a subtopic, energy conservation law. Energy conservation law. Under that, right, in a closed system, right? Closed system. In a closed system, energy is conserved. Energy is conserved. Conserved means doesn't change, right? Energy is conserved. Full stop. Only a one type of energy can be converted into another type of energy. One type of energy can be converted into another type of energy. right? Then below that, right, put a star mark. Mechanical energy, right? Mechanical energy is equal to what? Kinetic energy plus potential energy, Ke plus Pe. Below that, right, if mechanical energy is conserved, if mechanical energy is conserved, Ke plus Pe equals constant, equals constant. Below that, right, energy conversion, in that case, energy conversion, below that, right, in that case, energy conversion in that case, energy conversion occurs between Ke and Pe only. Kinetic energy and potential energy only. Right. So in this lesson, right, mainly we talk about mechanical energy conservation, meaning always we are talking about kinetic energy and potential energy. Then there's a energy loss as well, right? In some questions, there's a energy loss as well. That energy loss is usually what we call converted into heat, sound, those stuff, right? But most of the question here is if there's no energy loss, meaning it doesn't have a mechanical energy loss. If they say no energy loss means there's no mechanical energy loss in this lesson, right? So all that can happen is kinetic energy plus potential energy is a constant. Kinetic energy plus potential energy is a constant. If kinetic energy increases, potential energy decreases. Okay. If potential energy increases, kinetic no. If potential energy decreases, kinetic energy increases. In order to keep the sum of potential plus kinetic a constant, right? So this is a constant, right? If potential energy decreases, by the same amount, kinetic energy increases. Okay. If potential energy increases, let's say by 5 joule, potential energy increased. Kinetic energy decreased by 5 joule. Understood? So the energy conversion usually happen between only those two. So this will be clearer as we are doing questions, right? As we are doing questions, you will have a precise understanding of this, right? We'll move on to the questions, okay? Try 11th question. 11th question. You can draw a sketch. 11th question. So when you are doing questions, this line should be P equals 0, right? Meaning there's a reference line. I'll explain that. Okay, just try the question. Okay, let's see. So you know this has a potential energy, right? The potential energy this object has is mgh. So as it falls down, they say half of the potential energy is lost. Half of the potential energy is lost somewhere here. So the remaining amount is mgh over 2. If half is lost, this is lost amount, right? Remaining amount is this. So what happens to this lost potential energy? Lost potential energy has to convert into something, right? It doesn't actually lose. It only converts to something, right? So this amount converts to kinetic energy. So this amount converts to kinetic energy, right? So lost amount should be equal to converted kinetic energy. So what is the lost amount? mgh divided by 2. It is converted into kinetic energy, half mv squared. So half m cancels off, so v should be equal to gh root. So this is one type, right? One type. This is for less complicated questions. Usually you use this method to less complicated ones, right? Lost amount is equal to gained amount, right? Take it down. Same as like this, take it down. This is first type of solving, right? Write it here as first type. This is for less complicated questions, okay? If you're taking down, thumbs up, okay? Why can't we take height as h? This is h. This is ground level is 0. Ground level is 0. I don't know what you're asking. Ground level is 0. P equals 0. Above that, there's a simple h height. Is that the problem? Not height. It is not height. Here the height is h over 2, right? In order to make it, in the question they say mgh over 2. I think that's what you asked. I didn't use h height as h. I use height as h over 2. Is that what you asked? All right. Okay. Right. So this is first type, right? This is for less complicated question. If there's only one conversion, let's say here potential energy converted into kinetic energy. So you can say converted potential energy is decreased potential energy is equal to gained kinetic energy. You can say like that easily, right? But if there's like many conversions, right? Many conversion means this kinetic energy converted into potential energy, then kinetic energy, two or three terms. So in those types of questions, you have to go for another method, right? That method is energy here. So you are considering two states. Energy at state 1, E at state 1 equals energy at state 2. So this is a second type, right? Type 2. In the type 2, how can we say that? Energy here is equal to energy here. So it is energy conservation, right? Energy here is equal to energy here. So let's say how to apply that. So energy here, what is the energy here? At 1, energy is mgh. Kinetic energy is 0. Potential energy is mgh, kinetic energy is 0. Then what is the state 2? Here remaining energy, that is mgh over 2. Half is lost, but potential energy, this amount is remaining. Okay. Then kinetic energy. So the velocity I took it as v here, half mv squared. So this is the another type. This is used for complicated questions, right? Energy here is equal to energy here. You can use either of these, right? Either of these two types. You will get the same answer, but you cannot apply this method. You can apply this one for any type, any question. But this type is only for simple questions. I think yeah, you understand here. Then it is the same thing, right? mgh subtract, you get mgh over 2 equals mv squared over 2. So you get the same answer, right? Right. You will take that down. If you have any problem, let me know. Take that down. That is the same question done in two types, right? Done in two ways, actually. Something is not clear, let me know. When it comes to gravitational potential energy, you always mark this line, right? This can be any line, P equals 0 line. Here the potential energy is 0. Okay? Gravitational potential energy is 0 at this line. Above that line, it is positive. If something is above that line, we consider that to be positive. If the object is below, we consider that to be a minus mgh. Okay? Write note, then take this down. If it is above h, PE0 plus mgh, below minus mgh. Take it down. Right. Then we'll try a question. This will be more clear by a question. Try 15th. 15, right? 15th question. First draw the sketch. Take it down onto the book. Then try. Let's take this to be p equals 0. Let me know the answer if you get the answer. So what they ask is kinetic energy at C. Yeah, it should be 140 joules. Let's see. Let's see what is the potential energy here. Potential energy plus kinetic energy. So here what is the potential energy? mgh, right? So m is 2, 10, 14. 280 joules. Here the potential energy is 280 joules. Since it is released, initial velocity is 0. So kinetic energy is 0. So anywhere on this path, right? Anywhere on this path, total energy should be 280 joules. This is the total energy. There's no energy loss. Only this energy can be converted to the another type. Okay? Right. So the total energy is a constant, 280 joules. That is the total energy. Let's see here. What's the potential energy? Mass is 2 m g10 h5. 100, right? At C, potential energy is 100. So what should be the kinetic energy? 180 joules. Understood? Because the sum should be 280. Then let's think about here. Here, mass is 2, acceleration g, h7. So you get 140 as potential energy. Another 140 should be kinetic energy. This is potential energy. This is kinetic energy. So what they ask is kinetic energy at C. Yeah, answer is 140 joule. You didn't have to do all these, right? You only think about this point and this point, A and C. So any point on this path, it has the same amount of energy, right? So you cannot use linear motion equations here. because you can see path is not linear, right? So in all those cases you have to go for energy conservation. Understood? You don't I just did this to explain, right? But you don't have to do all these. You only have to consider energy at A and energy at C. Do you understand? Energy at A is equal to energy at C, right? So only thing that happened is potential energy has decreased by 140 joules. At C, by the same amount, kinetic energy has increased by 140 joules, right? So you have to understand the idea behind that. Okay? Yeah, answer is first one. Everyone understood? If you have any problem, let me know, right? I'm trying to explain the theory here, okay? Not necessarily the question. Did everyone understand? If you have any problem, let me know, okay? Okay, then try 16th. Question 16. You have to use energy, right? Don't use motion equations. You can use the motion equations, but here it is easy to use energy. First draw is sketch. Right. Let's see. So according to energy conservation, what happens? Energy here, this is the first case, right, is equal to second case. Energy at first case is equal to energy at second case. It doesn't change. So energy at first case, if this is P equals 0 line, this has a potential energy. What's the potential energy? mgh. Also it has a kinetic energy, half mv squared. Let's say mu is squared because there is u here. Then at E2, E2 potential energy, 0, right? At second case, potential energy 0. Kinetic energy is what they ask. Okay, then substitute. Mass is 0.5, G10, H is 20, plus half, mass is 0.5, U is, we don't know U, right? Do we know U? Here U should be given, right? Without that you cannot find it. Initial velocity should be given. Can you find without initial velocity? You can't, right? This is, please correct that, 10 meters per second. Initial velocity is 10 meters per second. Then it is equal ke. So this is 200, 100, 25, 125 joules. Take it down. No, initial velocity is not zero, right? How can the object move in a projectile? This object moves in air, right? Without an initial velocity, how can the object moves in a projectile? In that case, object would fall like this, right? Understood? Initial velocity is not zero. Got it? Otherwise, it cannot be in a projectile motion. Initial velocity can be zero if there's a solid path like this. But it is not solid path, it is just air, right? Okay, take it down. There the initial velocity must be given. Got it? Those who got that, try 17th question. 17. Draw a sketch. Draw a sketch, then try 17. So length is L. Mass simple M. At the bottom, they ask about velocity, V. It is released, right? Here the velocity is 0. Okay, it is released here. What they ask is velocity here, V. You can choose P equals 0 to be any line, right? I don't know which line you used. I'll use this one. You can choose this one as well. But the final answer is the same, right? You will get different equations, but the final answer is same. P equals 0. So easiest one is just energy at 1 is equal to energy at 2. So energy at 1 equals energy at 2. That is easy. Or else you can use energy conversion. Conversion means first type. We'll just, for now, we'll use second type, right? Energy is equal energy, yeah. It is easier. Easier to remember. Fourth one. Yeah. Right, let's see. So energy at 1. Potential energy 0, right? This line, potential energy 0. Kinetic energy also is 0 because this is released here. Then second, what is the potential energy here? This point is below P equals 0. So this potential energy is a negative potential energy. Before that, you have to find this height. What should be this height? Total length is simple L, right? Total length from here to here is simple L. From here to here, what is it? You have to consider this triangle. L cos theta. This length is L cos theta, right? Adjacent side cos theta. Then this length should be what? L minus L cos theta. Get it? This is L. This is L cos theta. Then this should be L minus L cos theta. But since this is below potential energy line, this potential energy should be negative value, right? So you have to minus mg L minus L cos theta. This is the potential energy at point 2. Then plus half mv squared. Because there's a velocity here, right? So it has a half mv squared. Right? So that's the equation. Energy at 1 equals energy at 2. Then get rid of m. I'm taking this to the this side. Take L out, right? So you get 1 minus cos theta equals v squared over 2. So v squared is 2gl 1 minus cos theta. Take the root both side. Root of that. Take it down. If you have any problem, let me know. Fourth one is the answer. Yeah, fourth one is the answer, correct. If you have any problem, let me know, right? So this is somewhat complicated. Doesn't matter, right? You just have to follow the same method. Take it down. If you have taken it down, thumbs up. Or then if you don't have any problem regarding this. Okay. Then try Then try 19. 19th question. 19th, right? Try that. First draw is sketch. So this is an exam question, right? So energy at 1 equals energy at 2. Uh, Take this to be P equals 0 line, right? Lowest level, take it to be P equals 0. There's a difference, right? Here there's a collision. You have to consider that here there's a collision. So you have to apply momentum conservation in order to find the velocity. Understood? If not, the answer is not correct, right? You cannot say energy here is half mv squared. You have to find the moment. You have to apply momentum conservation at 1. We discussed momentum conservation, right? So this bullet is stuck inside capital M. So if you apply momentum conservation, what happens? Before collision momentum is equal to after collision momentum for simple M and capital M. So what's the momentum before? mv. This doesn't move before, right? Equals, then these two attach together. So m plus m, let's say then it gains a w velocity. So from a side you have to find this w, mv divided by simple M plus capital M. So this is the velocity, it starts to move upwards with this velocity. So this is the initial velocity. Understood? W, right? Because for collisions you cannot apply, for all types of collision, this is an inelastic collision, right? So this has a maximum kinetic energy loss. So you cannot say energy here is equal to energy here. You cannot say that. But energy after the collision there is no collision. Energy after the collision is equal to energy here. Energy here is equal to energy here. But it is after collision, right? Just after collision. So just after collision, it starts to move at W to this side. Understood? If not, let me know. E1 equals E2. Energy here equals energy here. Here, P equals 0. So there's no potential energy. Because I chose to have this level to be 0, right? This only has a kinetic energy. So what's the kinetic energy? Half m plus capital M. Now it is stuck. W squared. Potential energy is 0. Equals here. Kinetic energy is 0. It is stopped here, right? Kinetic energy is 0. Potential energy is what? M plus M G this H. Then M plus M you can cancel off. So what they ask is simple H. Half W square divided by G is equal to H. Then you can substitute this W is something we added, right? You can substitute this W here and get the answer. Understood? So the only difference is for the collisions you have to apply momentum conservation, right? For collisions you cannot apply energy conservation because obviously there's a loss of mechanical energy in a collision. That is not obviously, right? So this is a perfectly inelastic collision. So perfectly inelastic collisions has a maximum energy loss, right? Okay, take it down. They're asking the speed, right? Yeah, it doesn't matter. Just substitute it here. Then you can, there's V, right? They're asking about V. Then you can, they're asking GH 2GH equals omega squared. Not omega, W squared. Then substitute W here. Then you can subject V. That's what they ask. Okay, take it down. And let me know the answer. Okay, let's see. So this is so W is 2GH root, right? W is 2GH root. Then substitute here. MV divided by M plus M equals 2GH root. So what is V? M plus M, 2GH root divided by M. First one? First one, right? Everyone understood? First one. So whenever there is a collision, you have to apply momentum conservation as well, right? Then using that, find the velocity. Then you can apply momentum conservation. Okay, then try 20. Next question. 20. First draw the sketch. There is also a collision, right? You have to apply, there's an energy loss at the collision. You have to apply momentum conservation for that. So first thing, you have to take this to be P equals 0, this level. There's M1 and the height difference is simple D. There's M2. So this M1 is released. Okay. So this hits here, M1. So just before collision, you have to find the velocity. Let's say U. You need to find this U, right? Just before collision. So how do you find that? Let's say this is 1, this is 2. Energy at 1 is equal to energy at 2. So energy at 1. that is m1 dg mgh m1 gd. You are applying that to m1, right? Equals, here totally converts into kinetic energy, that is half m1u squared. Mass cancels off. So 2gd root is u. U is equal to 2gd root. Okay. 2gd root. U is equal to that. That is velocity of m1 before hitting m2. Then collides, right? Then momentum conservation. Momentum before collision. Only m1 moves, right? So momentum is m1u equals, after collision these two attach together. Then let's say they start to move at v by attaching after attaching. So m1u equals m1 plus m2 v. So you find v. m1u divided by m1 plus m2. So this is the velocity. This starts to move here. Then let's say this reaches here to a height capital H. This height is what they ask. Then again you have to apply energy conservation to, let's say this is 2, this is 3. Energy at 2 is equal to energy at 3. Again you have to say after collision, right? Energy at 2 is equal to energy at 3. So what is energy at 2? Now there are two attached. It doesn't have potential energy. It has kinetic energy. And the velocity is not u, it is v. Equals energy here, mgh. m1 plus m2 g, height is capital H. m1 plus m2 cancels off. Then half v squared is what? This one. This one gets squared. m1 u squared divided by m1 plus m2 squared. This u also should be substituted from here. So what do you get? U squared is what? 2gd. U squared is 2gd. So m1 2gd divided by m1 plus m2 squared. This is capital H. There's a H as well. G here. This 2 and this G cancels off. What do you get? m1 divided by m1 plus m2 square of whole thing times d. This is capital H. So what's the answer? The answer should be second one, right? Take it down. If you have any problem, let me know. Everyone taking it down? Or if you have any problem, let me know. Right. So here we have applied energy conservation, right? To the collision, I applied momentum conservation. Then again I applied energy conservation, right? Then I just 3 times, right? Energy conservation, momentum conservation, again energy conservation. Got it? So these are the somewhat complicated questions regarding energy and work and energy, right? So this is I just only talked about a few questions. So by the next week I'll be able to cover majority of this one, right? Energy, regarding energy conservation. After energy conservation there is power and efficiency. For that as well I'll need 1 day, right? So within like 2 more days I'll be able to cover this one. So you will have a complete and excellent knowledge regarding energy and work and energy. Okay, right. So at the same time we'll meet by the next week. Okay, right. Then good night everyone.